Hello everyone. In this video, we will discuss about brushless DC motor drive, which is another important topic in the modern electric drives. So BLDC motor, which are widely used in the electric drives, robotics, and consumer electronics, due to their higher efficiency and reliability. So we will go through the basics and construction principles and the control strategies and applications into it. So let's begin with the quick recap of the BLDC motor. So a BLDC is a type of motor that uses the electronic commutation instead of the mechanical brushes. So it consists of a stator windings and a permanent magnetic rotor. So unlike the conventional methods, there are no brushes and which eliminates the mechanical wear. This controller switches the current based on the rotor positions to produces the torque, and the key advantages over here, which is a high efficiency, and we can have low maintenance and high reliability. So this slide represents a mind map of this overall BLDC motor drives. So it shows how different aspects like construction, control strategies, and power electronics applications are interconnected. Next, why are BLDC motors so important today? The traditional motors uses the mechanical commutations, which leads to the brush wears, and there comes the maintenance issue and lower efficiency and electrical noises. So, in contrast, BLDC motors uses the electronic commutations, which eliminates these problems, and they also offers the maintenance-free operations, higher efficiency, and typically around 85 to 90 percentage and clearer power delivery. So this makes them ideal for the modern applications. Next one is the core motor construction. So let's look into it. First we have the permanent magnetic rotor, which uses the material of neodymium magnet to create the constant magnetic field. Next, the stator, which contains the three-phase windings, so that generates the rotating magnetic field when energized. This position information is essential for proper electronic commutation. So next comes with the electronic commutation. So the working principles of this BLDC motor is completely based on the electronic commutation. So instead of brushes physically switching the current, an electronic controller energizes the stator winding in the sequence, which is based on the rotor position. So this creates a rotating magnetic field that interacts with the rotor magnets and producing the torque. At accurate time of switching is critical for smooth operation and efficiency. Next is the BLDC drive system, which consists of three main parts. The controller processes the feedback signals and generates the PWM switching signals. The power stages, which includes six bridge inverters, six bridge MOSFET or IGBT supplies the current to the motor. Then we have the feedback system, which uses the sensors to monitor the position, current, as well as the temperatures, and together these components ensure the precious and efficient motor operation. Next is the control strategy. So there are three main control strategies we are used in the BLDC motor. First one is the trapezoidal commutation, also called known as the six-step control. So it is the simple and cost effective but produces the torque ripple. And second is the sinusoidal control, which provides the smoother current waveforms, reducing the torque ripples and the noises. And but it requires the more complex processing. Third one is the field oriented control, or FOC. This is the most advanced method where the torque and flux are controlled independently. Next is the power electronic components. So power electronics plays a crucial role in the BLDC drives. The inverter bridge, which consists of six switches, which may be a MOSFET or IGBT, and we have the gate drivers, controls these switches, while the current sensor monitors the motor current, and DC bus is also there with a capacitor which stabilizes the supply voltages, and switching frequencies are usually between 10 to 20 kilohertz, which balancing the efficiency and electromagnetic inferences. And some of the applications and performance. So BLDCs are widely used in various industries. So in electric vehicles, they are used for the traction, power steering, HVAC system due to their higher efficiency. And in the industrial automations, they used in the robotics, CNC machines for the precious control. And whereas in the consumer electronics, they can found in fans, drones, and applications where compact size and quiet operations are required. So this makes them preferred in the modern engineerings. And let's now conclude with a quick summary. That is, to summarize this, BLDC motor uses the electronic commutation instead of the brushes, which eliminates the mechanical wear and increases the reliability. So this consists of three-phase stator and permanent magnetic rotor, and the power electronics ensures the precious speed, and the torque control uses the PWM techniques. And we have seen about the different control strategies which one will gives you the more efficient and good performance. So overall, BLDC motors are highly efficient and widely used in the modern applications. So these are some of the references I have attached. You can explore these material for deeper understanding of BLDC motor. Thank you.